Does this rock at last hold the response to the subject of life? The NASA meanderer tirelessness has found a secretive rock on Mars that shows the red planet could for sure have delivered extraterrestrial life. Exhaustively, the stone is decorated with some dull line tracks that contain iron and phosphorus. Also, it just so happens that such leopard spots on Earth are commonly created by microorganisms. So, have we at last found the microbial occupants of Mars? What ends can be drawn from this novel disclosure? And could our adjoining planets actually be stowing away extraterrestrial living things? Well, incredibly, the possibilities of this are not at all awful. Specialists have as of late found a tremendous repository of fluid water underneath Mars, which, in their assessment, could address a life-well-disposed world. What do Albert's theory of relativity and a thrilling find on Mars have in common? That's right. In both cases, it's Einstein's SL, a stone that has the examination world pausing its breathing. But all jokes aside, what steadiness found on the surface of Mars a couple of months prior does indeed have the potential to make it into the cosmic history books. The main point, anyway, is that the NASA meander has been on Mars since February 18th, 2021, where it is taking a close look at the scene and rocks of the Jezero crater. And of course, this isn't simply any randomly chosen landing and research site, but an area of nearly 50 kilometers in size, which was formed by a shooting star influence in the far-off past and, until 3.8 billion years ago, still contained a totally mature pit lake with feeders. It is now undisputed that cool fluid once sloshed in overflow on the red planet. Yet, the question of where all the Martian water has gone over time is far more dubious. Well, that's assuming it has vanished by any means. As a matter of fact, a new research study has come to the historic end that the water has in no way, shape, or form literally vanished immediately and inexplicably, but has simply moved underground. But favoring that later, while steadiness is inspecting the previous river delta in the Jezero crater, it's expected to gather material samples for transport back to Earth. On one hand, and on the other, look for potential hints of previous Martian life. Furthermore, as NASA declared in July of this year, the meander might have raised a ruckus around town exhaustively. The meander went over a very extraordinary stone arrangement on the northern edge of the ancient river valley of Nita that had never been seen before on Mars. All the more specifically, the object of interest is a stone around 1 m long and 60 centimeters wide, which specialists named Shava Falls, and which stands out with some tail follows. This is now the situation with the expansive white sulfate veins between which an unmistakably more obscure, rosy material sleeps, showing the presence of hematite. This is actually to be expected in and of itself, as this iron oxide mineral is everything but intriguing on Mars. Anyway, this expressly doesn't matter to the many spots, a couple of in size, that are embedded in the dark hematite stores. And while the little spots appear as unpredictably formed, grimy white dabs, they are encircled by rings of dark material. The most confounding, complex, and possibly significant rock, ensuing investigations have shown that the dim rings contain iron and phosphate. And what might sound to us simple humans like just an exhausting rundown of geographical items has the specialists totally close to themselves with energy. Ken Farley of the California Institute of Technology underlines that Shava Falls represents nothing less than the primary unequivocal proof of organic material on Mars. But that's not all. Simultaneously, Farley also describes the piece as the most baffling, complex, and possibly most significant rock steadiness has inspected up until this point. This is for the simple yet exciting reason that the colored leopard spots could show chemical reactions that microbial living beings use as an energy source. The spectrometer examinations showed that the spots and their environmental elements contain organic carbon compounds, and along with the phosphates and the iron, they are considerably more suggestive of those follows that are frequently related to microbial activity on Earth. Specifically, the terrestrial spot makers are many times organisms that have, when fossilized, left their remains in the subsurface. Iron and phosphate are normally produced when microorganisms reduce iron oxide. And as mentioned, Shava Falls was found in a climate that was considerably wetter billions of years ago and, therefore, may have created the best conditions for microbial life to thrive. But what does the discovery of the stone mean in opposition? As steadiness is now answered, what is arguably the most ancient question of humankind? Whether Earth is actually the only heavenly body in the universe to have produced life? With a resounding no. Well, not exactly, because the reality also includes the fact that while organic molecules on Earth often come from microorganisms, they can also be formed by geochemical. Abiotic means that don't require the involvement of living things. For example, we are aware of such molecules being formed in the context of volcanic activity. And if the material from Shava Falls was also heated by magma, we would need to rapidly rule out the possibility of microscopic Martian inhabitants. In fact, a grain of the mineral olivine, which is found as a solid part of magma, has even been identified in the stone in question. But it remains perplexing because the mere fact that there was once volcanism in this region doesn't necessarily mean that the leopard spots can have come from microorganisms. The Martian mystery, as we can see, still holds many strange problems for us. And, tragically, this won't change much soon. That's because the analysts point out that they have generally exhausted their remote sensing methods. At the end of the day, steadiness has already bombarded the rock with lasers and X-rays and shot it constantly from each possible angle. To understand the mysteries the Martian stone truly holds, researchers need to study it very closely, and that's only possible once the relevant samples have been returned to our blue home planet. But when the day of return transport has come, specialists will be able to use high-precision analytical instruments to determine if we are truly dealing with the fossilized work of Martian microorganisms or just the result of volcanic activity. And incredibly, it might be that Mars has, in fact, still not stopped its volcanic activity. According to seismic data from the Mars InSight mission, it has strongly suggested that magma chambers still exist within the red planet. But this is neither the only nor the most exciting mystery that Mars InSight has revealed beneath the surface of our planetary neighbor, because the test data also shows that a massive fluid water reservoir is hidden at a depth of 11 kilometers. And by massive, we truly mean massive. According to the specialists, the amount of secret water would be enough to form a planet-spanning sea, 1 to 2 kilometers deep. As briefly mentioned earlier, the question of where the water of the red planet has. The mystery of Mars' vanished water is quite possibly one of the best secrets of current Mars research. Until around a few decades ago, there were still streams, lakes, and even a large sea on Mars. However, an extraordinary environmental change eventually shut down the life-supporting conditions on the planet, causing the waters to disappear from the red, shining surface. The polar ice caps and the water ice in the mid-latitudes are not large enough to store all the water from the previous Martian ocean. For a long time, many scientists have believed that most of the water simply vanished into space. After all, it should have been easy for the solar wind to strip portions of the atmosphere, and consequently, the water, into space, due to the absence of a significant magnetic field. However, Vashon Wright's team at the University of California, San Diego, has reached the conclusion that the water loss might also be explained in another way. They propose that the water may not have vanished at all, but instead could have seeped deep into the Martian crust. To test this astonishing hypothesis, the researchers analyzed data from Marsquakes collected by the Mars InSight mission in the Elysium region between 2018 and 2022. In fact, the seismic data had already revealed that there is scarcely any water in the Martian crust at the landing site, but only down to a depth of about 300 meters. However, Wright and his colleagues looked further underground and discovered that beneath the dry, cold surface of the planet, there is indeed a hidden mystery. The investigations showed that the Martian mantle is, in fact, porous and sprinkled with cavities, as was previously expected. Additionally, the seismic data suggested that these fine cracks and fissures are filled with liquid water. In fact, these natural water reservoirs are likely to make up around 177% of the rock volume in the region. All in all, the gathered data can best be explained by the fact that the planet's mantle contains water in excess. For the sake of clarity, it should be noted that this finding is only applicable if the research results are representative, not only for the area where the Mars probe was located, but also for the entire planet. If so, however, the fascinating possibility arises that Mars could have a vast groundwater supply stored in its deep stone pores. Considering that the estimated amount of water in this case is enough to flood the entire planet to a depth of 1 to 2 kilometers, another intriguing question emerges. Could extraterrestrial life be found in Mars' underground water? Well, the scientists answer this question with a simple yet compelling yes. After all, we shouldn't forget that even on Earth, there are organisms that survive in extreme conditions, such as permanent darkness and a lack of oxygen. Michael Monga from the University of California, Berkeley, who was involved in the study as a co-author, is quoted as saying, "Since water is a prerequisite for life as we know it, I don't see why Mars' underground water shouldn't also be a life-supporting environment. While we have yet to find any proof of life on Mars, we now have a place that could, in principle, support life. And who knows, perhaps one day, future missions may uncover even more fascinating discoveries beneath Mars' surface."